Good morning, it's Tuesday morning and I'm on my way into the yard. Me and Dan are on our way up to Birmingham. Got a job on a shredder. We've been asked by the company to go and change the teeth on their shredder. It's the first time they've ever changed the teeth on this shredder, so they've asked us to just go in, change some teeth for them, show them what's involved in changing the teeth so their own maintenance guys can change the teeth in the future. Never done this shredder before. It's a bit of a different shredder. The teeth are actually bolted directly to the shafts. Could be an awkward job because there's a lot of bolts. I think there's over 500 bolts that hold all the teeth on. There's 52 teeth, I think, from memory. So there's quite a few bolts to come out, and they are going to be tight. So just heading into the yard now, get in the van with Dan. Me and Dan are going, and we'll go and have a look and see what we can do with it. So it's another week and another shredder, and on this one we're changing teeth. So let me just show you the teeth. This is the tooth that we're changing. I'll show you on the shredder in a minute. But the value on this pallet, I'm not going to say what it is, but it's nearly 6 figures. So we've got a load of these teeth to change. Some bolts in the box, big chunky bolts. M24. And they get torqued up to some horrendous torque. I think it's 970 Newton meters, which is quite a bit. We've got a special tool for that, torque multiplier, that we're using. So let me show you the shredder at the top and where these fit. So this is the inside of the shredder. The tooth that I just showed you on the pallet is that there, and they're bolted in. Got 5 bolts here and 3 bolts here. And I haven't actually worked out how many teeth there is in a ring, but we've got seven rings down this shaft. So 1 ring there, 2, 7 rings coming this way, and 6 rings that way. So this is the material that's been run through the shredder. All copper tubing, copper cable. Some of it comes from this place, because this place actually remelts the copper and turns it into new tubes. Some of it's seconds from where they make the tube, but most of it is bought in, I think, from other sites, gets collected in scrapyards and then comes to here to be reprocessed. So the way the shredder works is that shaft goes that way, that shaft goes that way, and the knives here grab hold of the material and force it between those 2 pieces there, like that one's through there. So it cuts against that radius piece there and forces it between these 2 bits and puts it into smaller chunks, and then from there it gets sent off, goes across a screen, and it goes down here onto that conveyor, goes up there onto a shaker deck, and any oversize comes up this conveyor and gets fed back round and re-shredded. So we're just taking out the copper plugs, like you can see there. That's copper that's been hammered in, and there's a bolt under there that we need to take out. So we've tried various different techniques for getting it out, and the best one that we can find is warm it up with the gas, get it hot, and hammer a bar into the middle and try and prise it out as a plug. But some of this is copper cable, and that's not that easy to get out. You'd think it would be, but it's not. It's compressed in there, copper cable, and it's not easy to get out. If it's just like this, for instance, if it was like that, rammed in there, that seems to come out easier than the cable. But we've done We've done some now. We just turned the shafts a bit more so we can have a go at some more. And then hopefully we can get it all cleaned out and then we can change these knives. So as is usual when you're using gas, in an awkward place, you run out. We've probably got a quarter or a third of these still to do and the gas is run out. So we've got the gas bottles up here on the scaffold, secured with the strap if anybody's wondering. It's not going anywhere. So customer's just gone off to fetch another bottle of gas, but we're going to have to lift that down, swap the bottle, bring it back up. So at the minute we're just trying to clean up the holes we can. So Dan's here with the die grinder, because although we've got copper rammed in these holes, we've also got the sort of slag. I think what they did, there's some blocks of molten copper that's still got the crust on the top, the slag on the top. When they melt, I don't understand the process fully, but when you melt copper or any sort of foundry application, you put different chemicals in there to bring the impurities to the top, and you end up with a crust on the top. And I think they've started to shred some of them blocks, and what we've got in the holes here is actually that hard compacted crust. It's like a hard set dust, a bit like concrete, that type of material. And that's also rammed in these holes. So Dan's just got the die grinder, cleaning that out of the holes. But the customer has already joked that the next time this needs doing, they'll be calling us. And I've said that we'll block their number. We're only joking. So we're going to clean these holes out the best we can. New gas is coming. And then we can crack on getting these changed. And we've got the special tool with us to break these bolts off. We put our 3/4 gun on this yesterday. Now today's Wednesday. We were here yesterday cleaning these holes out. We're nearly done. And we put our 3/4 gun on. And the torque on these bolts is 970 newton meters. Our 3/4 gun wouldn't touch it. So we are going to use a special tool, like a torque multiplier tool, to undo them. Because these are crazy tight. I don't think they're crazy tight. I think it's the fact that the material has been rammed around the side of the bolt. It's been forced down, and that's also gripping the bolt as well. I think if it wasn't for that, you potentially could be able to get them out, but we need a bit more oomph. So we've got the tool just for the job. So we'll finish cleaning these holes out, and then we'll start unbolting the teeth. So this is the bit of kit we're going to be using. Doesn't actually look, when you look at it, strong enough to do the job, but this is a cracking bit of kit. It's a torque multiplier, so this can tighten bolts to quite high torque. And what you do is you put the socket on here, and what you want to undo, and then as it moves around, and this bar here then comes up against something solid, so that goes in that position. That bar comes around against something solid, and basically it just undoes or tightens the nuts. Now the clever thing about this bit of kit is you've got a digital readout in here, which you can see, and you can adjust the torque setting. So you put in what torque you want the bolt to be done up to, and it torques it up to that torque, and that's it. Really, really clever bit of kit. Quite expensive, but a really clever bit of kit. So if ever you need to undo anything that's really tight or torque it up accurately, this is the bit of kit you need. So this is the bit of kit we're going to use on that machine. Undo them bolts, and hopefully this is going to save a lot of hard work. Comes in its own box with everything you need, and depending on what you do, it comes with a selection of the reaction bars. The yellow bar is the reaction bar, but the company that supplies this can supply all sorts of different reaction bars depending on the application, even specialist ones for specialist jobs. So really clever bit of kit. So shredder 1, socket nil. That is a brand new socket, 5th bolt, chewed it straight out. So we're just seeing if we can get hold of another one, possibly inch drive, because as I say, this was destined for a 3/4 gun. It's got a 3/4 2-inch adapter on it, and the intention was to use their 3/4 gun, because their 3/4 gun was double what the torque is for these bolts. But with all the debris that's rammed around the head of the bolt, it's just making it incredibly hard to undo it. So with the torque multiplier on it, it's just chewed that out. So we're just trying to get hold of another socket now, preferably inch drive like I say, and see if we can do something a bit different with that. But what we have considered. So it's Thursday morning and I'm just running the tool that we borrowed for that shredder job back to a customer of ours at Corby, who we borrowed the tool off. Very kind of them to lend us the tool. Just doing that now, and I've got a busy day today. We've got interviews for new general manager, because we're looking for a general manager in the business. We're looking for somebody to come in and manage the business on a day-to-day basis, because I am not the right person for that job, and we've grown to a size now where we need somebody who is the right person for that job. So interviewing that, got customer meetings, and have a catch up in the workshop and see where the lads are with the Mayglass Trommel and the oil screens, because I think they've been assembled now, ready to go out, as well as they've also started on the pallet conveyor as well. So I'll catch up with them today and see where we are with that. But I was looking up the spec for this tool that we've borrowed last night. As I said yesterday, the torque on those bolts on them teeth is 970 Newton meters. And what that means is, best way to describe it, if you had a socket with a bar on it and you were going to try and tighten it, and that bar was a metre long, 970 Newton meters is roughly the equivalent of putting 97 kilos of weight. So it's nearly as heavy as me. Put that amount of weight on the bar, that would give you 970 Newton meters. So socket, bar a metre long, put 97 kilos on the end of that bar, that would create a torque figure, or a turning force, of 970 Newton meters. And just to put that into context, I looked at the spec of the tool. Now, although the tool looks small and doesn't look as though it can do it, that will actually do 7,000 Newton meters. So that's the equivalent of your meter bar and putting 700 kilos. So that's nearly 3/4 of a ton on a meter bar. That's how tight that tool will get it to. And that is incredible. That's something you would never do by hand. Never. You'd need a bar 20 metres long to have enough power to pull on that to get it that tight. So that's a serious bit of kit, really handy, and we're really grateful for our customer for lending it to us. So I'm going to go and drop that off and then get back to the office for the interviews and my other meetings today. So we'll catch up in a bit. So it's Friday morning and we've got a mini screen going out the yard. Just flip the camera around. So Archie's just loading it up. This is going out to screen compost, I think. So customers come to collect it. Standard E21. Couple of meshes in there, 25 and a 15, I think. So customers come bright and early this morning, come to pick it up. I think it was ordered last week, paid for last week, come and picked up this week. Nice and easy, how we like it. Okay, so a little update in the yard. We've just purchased some new offices. Let me flip the camera around and I'll show you our current offices and what we're planning on doing with the offices. So this is our current offices. That's my office on the end, on the corner. Andrea's is the other side. And then these three windows here is an open plan office. That's where Paul, George, Melissa and Lauren sit. The two roller shutters that are shut, that's our meeting room. And then we've got yard toilets there that the lads in the workshop use. And then behind that is the office toilet, but we've run out of space. So we've just purchased another 5 units to go on top. The new general manager will have my office. So the plan is to have 5 new units across the top. This end will be 3 open plan offices for me, Andrea, Mel and Lauren. And then this end we will have a bigger meeting room, because this meeting room in here can be a bit tight at times. So we're going to have a bigger meeting room at the end. So we'll have a meeting there for customers, team meetings, and also we can do any training up there. Sometimes we have training for the guys in the workshop and we need a training space. So we're going to have some tables up there that we can rearrange and move around, and we can turn it into a classroom. There will be a television screen up there and a projector or something like that. And then this end will be open plan offices. So in the main workshop, the lads this week have been putting together the 2 oil screens. If you remember from a few episodes back, we were building these oil screens for a company in Birmingham. Well, they've all been assembled now, and we've had Sean in to come and put his control box. So we've got the control box with their usual sticker on it, with all the instructions and all the controls. There's a stop switch, because on the handrail at the top we've put an e-stop on there just in case there's an operator up there and he needs to stop it in an emergency. So we've got that covered. So we've got the distributor mounted at the top. You can probably see it all, this is where you're going to see it all together now, because in the past I've just showed you the bits and bobs all as separate bits, but now it's all assembled. You can actually see how it's all going to work. So the oil is going to go in that flange at the top. There'll be a pipe coming across from somewhere, and then it will go into there. The oil will then cascade, just coming down here. The oil will cascade down the back of the distributor, and then all the little bits of meat particles that will be in there will get filtered out by the screen. Just coming back under here. So all the solids, because obviously as I've probably already described in the past, the oil that's going through this is used cooking oil, and it's going to get put through a macerator pump, because mixed in with all of this waste cooking oil there could be chips, kebabs, all sorts of debris in there. So these screens are predominantly to take out the bigger bits. It's going to go through what's called a macerator pump, which is a pump which will chop all the solids up into smaller bits, and then coming down here will be anything less than 8mm. So we've got a 5mm stainless steel mesh on the top, and then we've got a 0.8 or 800 micron I think it is underneath on the bottom. So we're filtering the oil down to 0.8 of a millimetre. Now the reason they've got 2 screens is because they've got 2 separate lines, 2 separate input lines coming into their facility. So they will be putting one line through one screen and the other line through the other screen. Any oil that goes underneath will get caught into this stainless tank here. If you look just where my finger is, just there, you can see there is a level switch, and the plan is to connect that into the pump that feeds these screens. There is an outlet at the bottom which will take the clean oil away, and the idea is if there's a problem further down the line and the oil backs up and this tank fills up, that level switch will cut off the pump that feeds the top, so these tanks shouldn't overflow. So we've got these two here. If you've looked at previous episodes, you'll see that these bolt together. This one here comes around to here, so it's in like an L shape. And then these two sit on top of two of the frames, so these will be, I think it's about another 1.5 meters higher than this. And then we've got the walkway that goes around the outside for access. If you've seen us previous episodes, you'll see how that sort of all looks. But that's these two together now. These, on the actual schedule for the customer, ironically the customer actually wants these last, but I think these will probably go before we do the other stuff, because for this same customer we've just started making a big pallet conveyor that's in total about 50 meters long. So that's the next big project for the workshop. So lads have made a start on that already. Colin's next door machining a load of bits for that, which I'll show you in a minute. And we've also got a oil tank where they're going to put 4 IBCs on top of it, and then it will drain down. So they'll put 4 IBC containers. An IBC container is a meter cube plastic container, basically on with forklift pockets at the bottom with a tap on it. So they'll put the IBC on the tank, and what they'll do then, they'll drain it down, empty the IBCs. The tanks will sit at, I think it's a 2-degree angle, so they drain out. So then the oil will drain into the bottom, and then that will get pumped off, and eventually I think we'll eventually go through one of these screens, and then the IBCs can be took off and fresh ones put on. So there's 3 projects there. There's actually 4 actually. There's those 3 projects. There's also another project for them. They are having some gravity conveyors, which in a previous episode I actually went to site and had a look at. They've ordered 2 gravity conveyors, so they will take their deliveries out in the yard. They'll get forklifted off the lorries, be put on the gravity conveyors. The gravity conveyors will then take the pallets through a wall into the building where all the production is. It will go through the system, and then there'll be another gravity conveyor coming out of the building. So clean drums on pallets will then be brought back out of the building and be loaded onto a lorry to go away to be refilled. So we've got that to do as well. When I talk about gravity conveyors, it's basically a roller bed set at an angle, and the one that we're doing for them is quite funky. It's got rollers on there that actually break the pallet, so as they put the pallet on, the pallet will roll down the incline to the bottom, but certain rollers in there are braked. Very clever, and when we've got them, I'll show you them because they're very clever. And what they do is they slow the pallet down so it doesn't go crash into the bottom. So that's really clever, so we're doing that for them. The other modification we've also done recently on the pallet conveyor, which we'll show you when we get to, they wanted a walkway over the top. We've also got electric controls on that, so it's got start and stop on it. So if the operator wants to get to the other side, because on the other side of the pallet conveyor, they need access to somewhere. So the only way that they can actually get to access to this area of the building is actually over the top of the pallet conveyor. So we're going to do some steps leading up to it. There'll be a gate and a stop button, so they can stop the conveyor, walk across the top of the conveyor, so that the conveyor can't start as they're walking across. So it's all safe, so they can walk across. And then when they get to the other side, they can close the gate, press the go button, and then the pallets will keep coming past. So when we get to them, we'll show you them. Looks like Steph's welding these up. These are going to be, still warm these are, he's been welding them up just now. These are idler sprockets for one of the pallet conveyors. These are plates that we've cut in-house. Colin's machined a boss to go in the middle, and that's now being welded in. and these will then go back into the lathe and have the final bore done and circlip grooves put in there, because these are going to sit, let's see if these are cold, these are going to sit on the pallet conveyor, and I'll show you these when we get to them. They will sit like that and the chain will run round them, and then there's a pin that will go through the middle, and then there's a bearing in there that it will run on. These are all made in-house, come in as flat plate, cut on our plasma cutter, CNC plasma. Collins machined these bosses here, they were originally round bar, and then we'll do the final finish on the machine. He also puts a chamfer on the outside here. There is one somewhere that has been finished. Let me find that for you and I'll show you. So this is one that we've finished. Chamfer on the outside, got a pin in the middle. Now you'll see that the pin is slightly bigger diameter this side than it is this side. I don't know if you can see that, I've spun it around now. And what it does, the pin has got a shoulder on it, and the pin goes through from this side, sits up against the bearing, and then in there is what's called a circlip. I don't know if you can see that. And that circlip is on the shaft, just to stop the shaft from moving in and out, or the bearing moving on the shaft. And we've also got a circlip in there externally, so that the bearing gets slipped in and sits between two circlips. So that is solid now. That will get bolted between two plates, and the chain will run on that, and that will just rotate. And that is how we make the sprockets for that. Now, interestingly, we had a price for these sprockets from the people that supplied the chain. It was quite expensive. This turned out to be much more cost effective to do it this way. The chain's running at a relatively low speed, so these aren't going to wear out prematurely. They'll be perfectly fine for what this application is. So this is the chain that's going to run around them sprockets. Now this is a bit different to normal. This is special chain that's got the rollers offset. So this will sit, and these rollers will run flat along the top, and it's done so that the top sits higher than the rollers, and the pallet is going to sit on here, and then these will roll it along. Archie's just picked up that sprocket so we can put it in here, and you can see how it's going to fit. So that sprocket sits in there like that. This is an idler sprocket. We've got some other sprockets as well. There's these ones, Arch.
Yeah, then you're boring out a keyway.
So these are the bought-in sprockets, and what we will do, this is going to be the drive sprocket. So this will get bored out and keywayed. Colin can do that for us here, and this will be the driven sprocket, but these ones are going to be the idler sprockets, and that's why we've made these ourselves, because we wanted it done a specific way to fit the conveyor that we've designed for these guys. So yeah, special chain. Well, special chain in the point of view that it's not normal chain. Normal chain would normally have these links in the middle, these pins in the middle of the link, but these ones are a bit different. They're offset, so that this roller here will roll along the flat surface, and you'll put the pallet on the top and move the pallet along. This will all make more sense when we get it put together. So if you keep watching future episodes, it will all make a lot more sense. Okay, Trommel update for Mayglass. Now, if you've looked in the previous episode, we did an introduction to this, and we spoke about what we were going to do for a company called Mayglass. This is their trommel, and this is how far we've got. Now, we've got a video of the drum going in, so we'll just pop that in now. Bit of raw footage, bit of time lapse, and a bit of raw footage. So we'll put that in now so you can see how we put the drums in the trommel. Okay, so that's how we put the drum in the trommel. So let's just walk around where we are with this trommel now. We've made all the bunker panels underneath, shown that in a previous episode. We've made the base frame, and I think the last time you saw this base frame, we'd got the base frame done, we'd got these on, and I think we'd probably got the wheel mounts on. I can't quite remember what we showed you, but now we've got a bit more done. So let's just go in here and show you what we've got. So the drum has been made. Didn't catch any footage of the drum, which is my fault. I wasn't here when it was made. So the drum has been made. The drum's been made. 2 rings out of 8mm steel. Spoke about this before. 8mm steel is what's needed for these drums. If you go any thinner, they do go a bit egg-shaped. We've got bracing on this end. Got a support ring here, support ring there. Chain-driven drum with a sprocket that we cut ourselves in-house on the CNC plasma. It's a bolt-on unit, so if it ever does wear out, we can replace it. In all the years that we've done trommels, we've yet to replace one. So it does work quite well. And we've got some trommels that have run a few thousand hours now out there, and we've never replaced that ring. But if we do ever need to replace that ring, you can do. It's a nut and bolt job. Comes in 4 sections. You weld them together when they're on, not a problem. So drum ring here and a drum ring down the other end. We do a double thickness brace on here, because under there you've got what we call the 5th wheel. It's the vertical wheel, because the trommel drum sits at an angle. So as the trommel drum's working, it's constantly trying to push itself that way. So you have a 5th wheel at the bottom that comes on here to stop the trommel drum from finding its way out the end of the frame. So we put that on there. These are 8mm plates, and it's capped off with a 5mm cap across the top. And we've also got internal gussets in there. If you come around here, Archie, you can see we've got internal gussets inside, and they are flat plates that go between the 2 rings at set intervals, and they're tabbed and slotted into this side, because this side doesn't have anything running on it, so we can get away with this. But this side is smooth, and it runs around there on the drums. Now the drum wheels are here. We make these ourselves in-house. This is hard engineering plastic, basically like a hard nylon. It's bored out inside. It's got metal inserts pressed inside, sits on 2 bearings, grease nipples on the bearings, and we've also got slider adjustment on here, so we can actually track the drum like your car, where you have to go and get the tracking checked. Make sure your wheels are going in a straight line. We can actually adjust the drum here, because believe it or not, even at this angle, you can actually adjust them for the drum to go that way. So we actually adjust it so that it's true, and it runs straight, and it very slightly biased towards keeping the drum down this way. Because if the drum wanders, we end up with a problem with the chain. On here, let me just shut this door. This is the mount for the motor and gearbox. So there's a sprocket that sits in here, and that's what drives the drum. So if that drum's wandering, you will end up throwing the chain off. Now, big shout out to Steve with his sexy welding. Looking very good this morning on that. So that's the drum. We've also got this internal ring in here that also gives it the strength in the drum, but also stops the material from coming out this end of the drum. Something else that we do, giving away all the trade secrets this morning actually, of all the things that we do to make our trommels the way we do. We have cover plates. It's made up with 4 lengths of this channel, and at the end we have a cover plate, because one of the main selling points of our trommels is that as it rotates around, these bars actually lift and tumble the material. And Mayglass obviously process glass, and part of the process they want to break the glass up. So those bars there lifting the material and it cascading down and tumbling will break the glass up. But what you find is, at this end, you end up lifting the material and it can come tumbling down back onto the infeed, or worse, goes out the end of the drum. So we put these covers at the start, so as the material goes up, it slides down and stays at the bottom part of the drum. Once it gets past the infeed, then we can lift it and tumble it, because we've got mesh panels that bolt in here. Mesh panels that go from one side of the drum all the way around to the other half of the drum. So we've got 1, 2, 3, 4, 5, 6 meshes going into this. We've got a joining strip here. The meshes are actually already here. They will have a plate on the end, that sort of shape, and we'll bolt it up on these holes here and then around the other side so we can pull the mesh tight onto the drum. And this machine is also having a cleaning brush. So one of the reasons why we do 2 meshes to create one on here is because this bar here, every time it goes around, does not hit the brush, but it disturbs the brush. So the fewer number of these that we can get on there, the better. Every trommel that you see with this sort of setup, and this is a fairly typical setup that has a brush on it, you'll see that it just catches every time it goes around. So the fewer number of these that we can get on there, the better. So we've got 2 on here instead of 3 or 4. So that makes it better for the brush. So the brush will fit on this side, I think. There'll be a brush going up here, which we'll show you in a future episode because we've not got that far yet. It will be a bristled brush. It's about 600-700 mil diameter, sits on a couple of bearings either end, and that sits on the drum with the bristles sticking into the mesh, probably about 10 or 15 mil, no more than that. And the idea being that if anything gets stuck in the meshes, it will poke it back out and keep the meshes clean. So that will go on in a future episode, and we'll show you that. We make that all entirely ourselves out of brush sections, so we'll show you that. I think that's about it, as much as I can show you in here. And then the lads have just been putting the doors on. We've got another door just there, which for the other side. I think they've started taking the doors off now, so they can go away to be painted. So obviously we test fit everything, make sure it's okay before it goes to paint. Because we're not in a high production environment and everything is hand built, we do spend quite a bit of time test fitting things to make sure everything fits. So when it goes to paint and it comes back, everything fits perfectly. Doesn't always work that way, but we do try to eliminate any mistakes and mess ups and kerfuffles as much as possible. So they will now come off and go to paint and be stored somewhere safe. And then the next job on this is to do the infeed. Material's been cut. I think Archie, you've already folded
most of it.
Archie's on the camera this morning. That's why it looks really professional. I'm not holding it at arm's length. So Archie's folded most of that now. And now that we're in this position, Steve next week will probably make a start on the infeed, won't he?
Yeah, we'll have someone on the infeed, someone on the hopper.
Yep.
And they'll come together at the end, and then that'll be, again, test assembled into the drum, onto the frame.
Yep.
Make sure it works.
So hopefully by the end of next week, sort of time, we might be somewhere near to have all of this put together, and then it's the big strip down, start getting it all painted, and then we'll get it back into our new assembly area at the far end of the workshop, where we can start putting all this back together, all painted. I think we've got everything for this now. Motors and gearboxes are in. The head drum for the infeed, which was done really early on, that's been back a week or so, isn't it? Yeah, so that can go on. The tail drum's been done. Motors and gearboxes are here, chains here. The belt is here for this as well, isn't it?
I think so.
That's that over there on that pallet there. So we've got everything here for it. So we just need to get the infeed finished on this, get it painted and get it assembled, and then this can then go out the workshop. So I mentioned a minute ago about the roller being back from lagging. Now we've got 2 rollers here that have come back from lagging. One is for the 5th conveyor to go to France, and the other one is, which I think is that one there is for the infeed up there. So when we say about lagging, it's actually a rubber coating on the outside of the drum. Now you can see the drum's all been machined up, and that's basically the tube that creates the drum, and we send them away to a company that put the rubber coating on for us. And I am not 100% certain how it works, whether this is actually put on flat, whether it's actually sprayed on or whatever it is, but I do know that it has to go into an oven, and I don't know if it's pressurized and heated, not sure on the process, but somebody in the comments may be able to answer that question. But basically they bond a rubber coating onto the outside of the drum. And the idea is that you've got a rubber coating on there, the conveyor belt runs around here, and rubber on rubber gives you a good positive drive and shouldn't slip. And because this, in the Trommel, we've uprated the gearbox and we've uprated the infeed because it's glass, it's heavy, it's dense, and we need to make sure that the belt moves when they put a load of glass in the top. So we've uprated everything to counteract that. This is also going to be having, instead of normal rubber side skirts, this will have nylon side skirts on it, because I was worried that if we went with rubber side skirts, within a day the side skirts would just be ripped out because of the glass going into it. So even they've been uprated. So we've got a lot of weight in there. I think we worked it out, we could potentially have 1.5 tons of glass on the belt. So the last thing we want to do is have the head drum slip or the gearbox trip out because it's not man enough. So we've gone overkill on everything to make sure that it doesn't cause an issue. So it's a wet morning and it's the day that we load out the 4 conveyors to France. We've got a truck backed in. We've got Hampsons here with their Hiab. Just about to lift these on. This trailer is taking the 2 smaller conveyors. So this truck is going to take these 2 smaller conveyors and is also taking the legs for the bigger conveyors. So these are now all ready to go. We're going to get this truck loaded up and get it on its way to France. Recording?
Yeah.
Oh, you do the little thumb as well?
Yeah.
I thought it was just your mum did the thumb.
Want to know?
You doing the thumb as well?
Okay.
Oh, okay. Are we ready?
Yeah.
Okay. Then I'll move a little bit. Okay, so that's how we put the drum in the trommel. So let's just walk around where we are with this trommel now.